Welcome to Robotics and Automation News webinars, where you can be part of a global event without leaving your home or office. Attend our live webinars and communicate directly with influential professionals in your industry.
Hello, my name is Abdul Muntakim. I'm editor of Robotics and Automation News.com. In this interview, I speak to three people who have been involved in the development of a disinfecting robot and what could be called a mobile communicating robot, which operates in an elderly care home and can talk to the residents and provide information. The three people are Jonathan Byrne, data scientist at Intel Movidius, Conor McGinn, CEO at Akara Robotics, and Niamh Donnelly, co-founder at Akara Robotics. Although I found it a bit difficult to talk to three people at once, I think the interviewees were able to keep track of the wide-ranging conversation, even if I could not.
My name is Jonathan Byrne. I'm a deep learning data scientist in Movidius, and I work on applications of the technology. So we're trying to build on the hardware, and we're also trying to come up with new applications for our chip. The focus of Movidius technology is computer vision on the edge at low power. So we are in things like drones, camera systems, robotics platforms. And the idea is that we have hardware that will do all the acceleration and run things like neural networks or standard computer vision algorithms at low power.
Thank you very much. Let's go to Conor.
My name is Conor McGinn. I'm an assistant professor in the School of Engineering at Trinity College, and I'm also the CEO and co-founder of Akara Robotics, which is a robotics spin-out developing healthcare solutions to both enable healthcare workers and also protect against the effects of COVID. So I'm leading the project to develop a robot called Violet, which is a disinfection robot for use in hospitals, nursing homes, and a range of other settings where improved infection control systems are required.
And Niamh, would you please introduce yourself?
Sure. My name is Niamh Donnelly, and I'm a co-founder at Akara Robotics, and I lead the AI and machine learning behind some of the robots that we build. So with Stevie, the robot that was building out Stevie's kind of social artificial intelligence, and with the Violet robot that's building out the computer vision system and navigation systems.
Okay, what I'll do is in a minute, I'll share my screen and go to both the website Intel and then Akara Robotics or vice versa. But before I do that, would you mind explaining the relationship between Intel Movidius and Akara Robotics? The nuts and bolts of it, I don't know really much about it at all. Jonathan, perhaps, yeah.
Sure, yeah. As part of our kind of outreach and helping people develop for our platform, we've started an incubator. It's the second year running it now. And, trying to get low-level electronics and deep learning, into your product is quite tricky. So what my group do is basically run a 6-month incubator where we provide support and help people build data sets, train networks, develop computer vision pipelines, and then get it running on our hardware over that time, with the intention of them using our chip in their product, and then when they become really big, we'll sell loads of chips. But essentially, we're just basically helping build a community of people who can use our technology and can use deep learning. As part of this, Akara joined us in January, where we were working on Stevie. So Conor, do you want to maybe take over there and explain the rest?
Sure. So Stevie was quite a different robot than we're currently working on. Its main applications were for retirement community settings, and working with Intel, our focus initially was on developing the ability for Stevie to be more aware of its surroundings, especially in applications where it needed to interact with older people and staff. And then as the incubator wore on and as the COVID crisis started to emerge, we saw an opportunity to take some elements of the technology and apply it in a healthcare setting. Namely, some of the research that my team and I were doing in the lab in Trinity College, which was looking at UV disinfectant lighting and the effects that can have to kill germs and bacteria and obviously the coronavirus. We started to move from developing applications in the kind of social AI space using Intel technology, instead trying to take that and pivot it so that we're now developing it for use in radiology settings in particular, so that we're able to control when a UV light turns on and off depending on if people are near it or not.
Niamh, would you like to give your perspective about how the relationship between Intel and Akara is working or works?
Yeah, I guess as part of the incubator, I was kind of one of the main people on the ground and kind of working with Jonathan and the team. So it was kind of my goal to build out some of the functionality on Stevie's computer vision system. And so on a day-to-day basis, I would interact with Jonathan's team, get feedback about models. Really, we were trying to run, I think it was 5 different models through a pipeline in real time. And so we had kind of set ourselves a very difficult task, and Jonathan's team were helping me speed up some of the models that we had already using the Movidius technology.
Okay, thank you. What I'll do now is I'll share my screen and go from there in terms of well, I'll go to the websites of the 2 companies. So this, I believe, is Intel Movidius. Jonathan, if I could ask you, so what is Intel Movidius? If you could just give us a brief explanation. You said you're a deep learning scientist. I'll ask you about deep learning in a minute, but just give us a brief idea of what Movidius, the Movidius part of. I know it's an incubator, but is there anything? What's all this deep learning and neural compute? What's all that about then?
Interestingly enough, my boss, David Maloney, set up the company Movidius in 2005. And their intention initially was to build a system for low power graphics cards for mobile phones. That was their intention. And that worked reasonably well up until 2008, when they decided to pivot. Basically, the iPhone came out and wiped out their whole market. So as any good startup, they decided to pivot at that point and work out what they were going to do. And they realized that there was loads of cameras. Cameras were becoming ubiquitous to every single device. And they worked on making an embedded system, hardware that could handle camera input and could do basic computer vision tasks. That came out as the Myriad 2. That was their first big commercially successful chip. One of the things, though, around 2012 was computer vision started moving towards deep learning. And deep learning, a lot of the main applications like classification, object detection, all came around at this time. Now, they made it work on the Myriad 2 chip, but what they really needed was custom hardware. So the Myriad X was their first chip that was custom designed from the bottom up to not only do computer vision, but also to handle deep learning networks. And to do this at low power. That's the main thing. Is if most deep learning is done in a lab, or on a supercomputer where it is, using, a very expensive NVIDIA GPU, which costs maybe $600 to $10,000, and it's using 350 watts of power. Our chips are designed to use less than a watt of power, handle the input from multiple cameras, and do computer vision and run neural networks. So it's a niche thing. It's for the edge, but the edge is now becoming the edge of the cloud, essentially. So the idea is, we have all of these sensors now that are generating massive amounts of data. For example, if you had a camera system that was monitoring like a car park, and you had 20 cameras recording each floor, like to report back that if to send all that information requires gigabytes of data being sent around the network, when you can use our chip to basically say there are 5 cars on the floor, and then you can send back, an integer value every 15 minutes. So it makes it much more efficient. You're only sending back the data you need, or only processing the data right where it's being generated at the source.
Okay.
Is
Thank
that
you very
sufficient?
much. Yeah, that's good. I'll come back to it in a minute, if you don't mind. But
Sure.
wanted to go to the guys at Akara there, the people at Akara there. How do you use the Movidius technology at the moment? Can you give us some specifics without, maybe, confusing me? I'm not really an expert in how things are built and all that. How do you use the chip? Do you use the chip that Jonathan was talking about?
So I suppose that one of the big challenges you have on a robot, especially a mobile robot like ours, is that you're very limited in what you can do on board it from a space perspective and also an energy and a power perspective. Obviously, there's a fixed volume that things can take up, and we don't have the luxury of having multiple PCs. It's difficult to send all the information you collect on the robot to the cloud for a number of reasons. Latency can be a problem, but also so can GDPR and the privacy side of things. So it's advantageous for us to be able to do things, as Jonathan says, at the edge. So when we started working with Jonathan and his team, the first kind of question was exactly how can we harness this? And one of the kind of key areas was the visual perception system. That's being able to understand what's happening in the close proximity of our robots. So very quickly we increased the number of cameras that we had on our platforms to give us a better perspective. It's quite common in the industry for a robot to maybe have one or two cameras. Our newer robots now have a 360-degree view, which is really great because it means that the robot has an eye in the back of its head, so to speak, and it's able to take actions that reflect that sense of awareness. So first and foremost, computer vision system. We're also using it where it's not possible on our robot to run these deep learning models because we just don't have the space for big GPUs. So even now we're looking at algorithms that have nothing to do with computer vision, but they're deep learning algorithms nonetheless. We're able to actually use a USB powered compute stick that allows us to kind of offload some of those things. And even more recently, we started to work with a company called Luxonis, who are an external third-party company, but they actually build custom embedded systems using the Myriad technology. And we're working with them at the moment to build a custom solution for our new robot Violet.
All right, Niamh, would you like to give your perspective, talk about the robot a bit more? I'm at the Akara website, as I'm hoping that you can see, and hopefully the audience can see as well. And this is the robot in question, Stevie, or rather is one of the robots Akara develops, and this is Violet, and it is a ultraviolet light robot. Now, I'll talk about ultraviolet light robots in a minute in general, because I've seen quite a few of them being released at the moment, ultraviolet disinfecting robots. But before I do that, Niamh, would you like to elaborate or add to what Conor has just said?
I think he's covered mostly everything. I suppose the ease of use of Movidius technology was something that we really benefited from. So as I said before, running that pipeline of algorithms was very slow. I think we were getting, we were processing about 1 to 2 frames a second, and within a couple of weeks working with Jonathan and his team and implementing the Movidius technology, we were able to even speed up the frame rate to, I think it was 10 to 11 frames a second. So, it was really, really helpful to be able to use the technology to improve our systems.
So what with the when you say 10 to 11 frames per second, where is the camera? Is it? Were you talking about the robot Stevie there?
Yeah. So that was.
So where's the camera? These two the cameras just on its shoulder,
Yeah,
or
I can't see the screen. I can just see a Google screen, but yeah, they're at the front. There's 2 120-degree view cameras at the front and one at the back. So it's really important in robotics to kind of have a 360 view, particularly if you're navigating or even teleoperation.
Yeah, sorry about that. I didn't realize my screen sharing had been paused. I don't know why that was the case, but I'll share my whole desktop this time. Hopefully I don't have anything embarrassing on there, but yeah, all right. So can you see that?
Yeah.
Yeah, so I can see on his chest that there's I'll go back to Jonathan in a minute, but that looks like an Intel RealSense or whatever camera system. And there seems to be two cameras, one on each shoulder there. Is that all the cameras it's got? Somebody mentioned, I think Jonathan mentioned, or maybe Conor mentioned, there's a camera on the back of its head or something. Are those all the cameras that it's got?
Yeah, and there's one at the back as well, and then there's actually a pop-up camera that ejects from the top of the head. Well, not ejects, but pops up from the top of the head.
Right. Oh, there we go. It's over here. I can see it in this picture on the left, a pop-up camera out of its head.
Yeah, that's
and as well, we should mention as well that the robot we were developing, the system for, was actually the upgraded version from what we're looking at the moment. So we actually haven't released that platform just yet, but it's similar enough.
Yeah, I see. That's interesting. I'll try and drop in after the interview. Maybe I can acquire some sort of newer pictures, even if it's still images, and drop them into the video during the editing stage. Jonathan, if I could come back to you,
sure.
If I can maybe, has my screen sharing suddenly been paused again?
I can see. Yeah, I can see your screen.
All right, I'm going to go back to the Movidius. Won't let me now, but yeah, I was just going to ask about cameras. The Intel RealSense seems to become really popular in the robotics sector. And in general, cameras are being developed more. The importance of cameras are being, it's kind of increasing in the robotics sector for all sorts of reasons, not just the kind of service robots, I suppose, that we're talking about with Akara, but also industrial robots and all kinds of robots, and maybe even autonomous cars as well. But they tend to be concentrating on developing LiDAR a little bit more. But the cameras that Intel seems to supply, the RealSense or whatever it's called, it does seem to be quite popular at the moment. Can you give us an idea of what that's about and how data processing and all that plays a part in such cameras?
I can speak as someone who plays around with robotics, in the sense that, 10 or 15 years ago, it was the Microsoft Kinect. That's what you were building your product around. Because it was the only way to get low cost, active sensor computer vision. Whereas, and then Microsoft stopped supporting it. So, that's what the RealSense is really coming into play, because they're making these very compact sensors that will give you, not just camera images, but for example, if you're looking at a RealSense, it's going to give you stereo depth of very, very high quality. It's going to be auto-calibrated. It's going to have all this sort of stuff that just works out of the box. And they're fantastic. Another one, though, that has our chip in it is the T265 RealSense. And what that does is that gives you SLAM, or visual odometry. And that basically means as the camera is moving, it will work out where it's moving and will basically have an understanding of 3D space. And now a lot of them, what you're seeing is they're pairing them up. You'll have a T265 camera combined with the 435 camera, and it means that basically you can use these sensors for understanding your environment, understanding where you are in the environment very easily. And because they plug into a lot of robotics platforms like ROS, most people, this is their kind of go to get something working and get something of very high quality very quickly for a reasonable price. If you're looking at other time of flight sensors and stuff like that, you're starting at €10,000. whereas these real sensors are 300 or 400 euro.
So you said T265 real sense. Yeah, let me see if I can find it.
Yeah, that's it. Yeah.
Yeah, so this is the T265. These cameras are growing in popularity. I didn't know the difference. I thought it was just one real sense camera. I didn't think there was various versions of it. They're becoming really important. Cameras in general are anyway, but this is something that Intel seems to have caught the wave on, certainly with startups like Akara. They seem to like using it. It's quite a nice looking camera as well, in terms of what are some of the specs in terms of what kind of resolution and data rate and things like that you can tell us about, highlight.
So what we can do is, okay, if you're looking at something like stereo depth, and you're doing this manually and you're trying to set this up yourself with 2 webcams or something like that, it's very tricky. You need to make sure that they're not rolling shutter. That can make a mess of it, because what you're doing is you're taking 2 images and you're working out a disparity map between the 2 of them. Okay. So that's where the real sense is really coming into play. Is it solves all those problems. You don't have to worry about the cameras being synchronized. The distance between the cameras, it's all very carefully calibrated. Like if you're working with this and you're trying to position 2 Raspberry Pi cameras or something, it's very difficult to do yourself, whereas this works out of the box. The same with the T265. What this does is actually uses 2 wide angle lenses, so it's got a huge field of view, and what it does is it's looking for key points in the image. So it's looking at corners, edges, patterned surfaces, and then once it has those key points, it can track those key points between frames, and then it knows where the camera is moving. So that's like very, very powerful. If you try and do that yourself, like if you try and do that on a robot, the standard approach is using an IMU, which will basically use a bunch of accelerometers to detect motion, but that can drift. So the big example for the big breakthrough for our chip was when we got into drones. So the DJI Phantom 4 was the first drone to actually use our technology for navigation, collision avoidance. And the whole reason behind that was, drones are very, very powerful, but the only bearing that they had on where they were was the position of a satellite 30,000 kilometers away. If it lost signal to the satellite, it would essentially just float away off into the distance. But when they used our cameras, and I think on the first drone they put 8 cameras, now I think they're up to 10 or 12 cameras per drone. They're all being processed by our chip, and we're using all those inputs to see are we going to bump into anything? Are we moving? Is the IMU working? Is the IMU picking up everything that, if you're like, if you have an IMU and there's a wind blowing it, it can move very gently without the IMU noticing. So they use the cameras to also measure that. They can also use it for tracking. So if you want to go jogging and have the drone fly behind you, you can do all of that with the cameras. So it's not just like the camera technology. What our chip is doing is making it a smart camera that can do more. And actually understand the environment that it's looking at and relay that information back to the robot, and that's hugely important.
Yeah, I'll ask you about the data side of it in a minute. I know I won't be able to keep up, but with the camera, the reason why it makes sense and it intrigues me as well is because what you've got with it is, the way it's designed, it's similar to human eyes. So the reason why we've got 2 eyes is each one, kind of, I don't know how to explain it. It allows us to understand depth and distance, and because of the angles of our eyes or the 2 angles from which it's, but both our eyes obviously need to be connected and processed. The data needs to be processed by our brain about position of an object in relation to each eye, and then some sort of depth sense from that. That's from a human sense, and up until now you mostly only saw cameras single cameras, single lens cameras on robots and things like that, probably because they didn't need to have as sophisticated a vision as some of the robots, like, for example, Akara is developing, which need to move around in 3D space and do all sorts of other things and detect distance. And I don't want to mention other companies in this interview, but I recently read that a certain tablet computer maker is using LiDAR in its tablet computer. What do you think of things like that? I mean, how do you think cameras will develop in general going forward? Because this is, I think, quite an innovation, to be honest with you. I haven't seen two cameras sort of almost human-like sort of principles being applied to robot vision or machine vision.
Yeah, I mean, it's funny, if you look at the academics, they use a thing called monocular SLAM, which is essentially using one camera. And the reason they do it is because they're academics and they really like making life difficult for themselves. It's like, I can win a marathon hopping on one leg. You're like, okay, but maybe it'd be easier if we use two. That's what that's what we found with a lot of this hardware is two cameras just, it makes stereo depth a lot easier because you know everything, there's a word for it. I can't remember. It's not the disparity. It's the base or the distance between the two cameras. If you know that piece of information, you can work out a lot of stuff. You can automatically work out the scale of objects and stuff like that. That's where two cameras become very useful. But you just mentioned LiDAR there, for example. So Intel is coming out with a new sensor that has LiDAR. I think I actually worked in a research group for 3 years where we did aerial LiDAR, and I think it's fantastic. So if you do Intel, yeah, there you go, 515. What's crazy about this, though?
It's the same, sorry, it's the same camera sort of family, if they like to call, the companies like to say family range, I like to use them. But it's the same kind, it looks like the same camera, shape and everything, looks like the same range of cameras, is that right?
Yeah, so I mean, there's advantages and one of the things is if you're using passive stereo cameras, that's great. But what happens if you go into low light conditions? It doesn't work. What if you use active stereo where it's sending out a signal? Well, if you go out into a really bright light, that doesn't work. What if you have an object that just can't be seen by, light? When you use a LiDAR sensor, it can pick up stuff that other things can't. So I think now in robotics, what you're finding is that there's a huge drive towards like multimodal sensor fusion. And that really is the only way that you can solve all the problems. If you put all your eggs in one basket and go with one technology, it just doesn't work as well. There'll always be edge cases that your technology will have a weakness to. And what this sensor here, I was talking to the guy because this gets me very excited. When we were working with LiDAR before, our LiDAR sensors were €50,000 for like a ground station, and they involve a spinning mirror. They have very mechanical parts to it, which means that even you look at the ones on drones, what do they call them? There's very simple LiDAR scanners, but they're all mechanical. They involve a mirror that is spinning around, firing out the laser. And normally at very high speed. The problem with this is if it takes a hit, if you crash your drone and it has a LiDAR scanner on it, it is gone. You have to recalibrate it because it could be doing 3,000 RPM and it'll just blow itself to pieces. What's really nice about this scanner here is it's using a solid state MEMS technology. So there's a small moving mirror, but it's tiny and it moves very small amounts and it's built into the circuitry. It's not a big mechanical device that's doing the spinning. So, that's where Intel and the RealSense devices are really kind of, going out there and trying to tackle every modality and at a reasonable price too. You want to buy a solid state LiDAR scanner, €50,000, and these guys are doing it for $350.
That's amazing. I'll have to look into that and learn a bit more about this subject. I just want to dwell on this image. I hope you can see it. It's a robot moving along what looks like a warehouse floor, and it seems to have its sights trained on boxes and all that. Now, this is interesting to me because I've been covering a lot of, or coming across a few stories about warehouse robots, mobile warehouse robots that have shelf units on the back of them moving around a warehouse. They're selling very well. But one of the things that they're trying to develop, the industry, some of the companies trying to develop, is putting an arm on the back of these mobile units, wheeled robots, and having that arm pick out items. So let me try and explain simply. At the moment, the mobile robots that are used and proven as technologies are the ones that have shelf units on the back of them. They bring those shelf units to a human person who remains stationary at what's called a picking station. And then that human picks whatever item they need from the shelf unit. If I order, me as a customer, consumer, order like 10, 15 different items, theoretically, that could be 10, 15 different robots coming to that human and that human picking out one item from each shelf unit from 10, 15 different robots. It works at the moment because the human walking around a warehouse is a lot slower than the robot moving shelf units to a stationary human to pick. But what they're trying to do is develop a robot arm that can be positioned on the or installed on the mobile unit and going out and picking that specific item or a range of specific items and then putting it in possibly a basket and bringing in the whole, fully complete order to maybe a human at the end of the chain. But that all is very challenging. And I think that a lot of it depends on vision, camera systems, good enough camera systems. Now, what do you think, as an expert, what kind of technologies are we looking at needing in that situation, and how far are we from, a technology that is good enough? Like a human would be easy. It would be easier for a human to go around these shelves, pick out the exact items needed, and put it in a bag or a basket, and then fulfill the order. For a human, it'd be easy, but for a robot, it's very difficult. Why is that, and what can we do about it, Jonathan?
Interesting. So I worked on an EU project called Refills, where it was in conjunction with KUKA, big robotics manufacturer, DM Drogerie Mart, which is a store kind of like Boots in Germany, and University Bremen and a couple of other universities, where we were trying to build a robot that could restock shelves. The interesting part was, what I hadn't realized is stores are like a black box. So warehouses are great. Warehouses are very, very controlled. But it's a very, we were going even further. We're trying to restock the shelves of a shop. And one of the things that really surprised us is, even though they have all of the tracking, the shop is a black box. They tell people they have a planogram, which basically says, here's where we put stuff on the shelves, and here's how stuff comes in, and we know it goes out because we scan it with the barcodes, and we know what's being sold and when it needs to be stocked back up. And we basically split the project into three pieces. One was depalletizing stuff. So as these big pallets come in, taking stuff off pallets and putting them into a trolley that then can be brought out to the humans to restock the shelves. And then we were looking at, how do we move stuff out of the pallets? And even then, that was, our job was to perceptually check that the stuff was on the shelves. So we had to come up with an algorithm that would identify correctly with 99% accuracy the product is on the shelf, and make sure that it's the right product, that they're in the right place, and to count them, how many of them there were. At the start of that project, I thought my part was the most difficult part. But in the end, we managed to do all the visual stuff fairly easily. We managed to be able to come up with an algorithm that would recognize the products and work out whether it was the one that matched the barcode that was there. We managed to count the products. The really hard part was getting the stuff in and out, which really surprised me. It was the hardware. It was the robots. How do you pick up a cardboard box? What about all the different types of cardboard boxes? What about ones where they have to go out with a loose lid? What about, trying to stock the items on the shelf? In the end, they realized that actually putting the individual items onto the shelf was the hardest part. And although they did develop a careful set of grippers that had sensory information, essentially the solution was to bring out the stuff to a human and then show them with a laser where they should be putting the stuff, so to aid them as much as possible. But it's just in a warehouse, maybe it's a bit easier, if everything's on pallets and you're doing everything in forklifts. But as soon as you try and move away from that, the robotics for that part was very hard. The robotics part for tracking the objects or understanding what is on the shelf and how many of them there were, that part turned out to be okay. So the thing is, they definitely needed a perceptual system to do it, but in the end, it was the hardware guys that ended up struggling the most to get it working.
That is really interesting, because I've always thought that hardware, maybe I'm looking, I don't know if I'm biased, but it just seems that developing hardware at the moment in robotics is more complicated than the software in a way, because you are talking about, humans have hands, fingers, and, very complex maneuvering capabilities, which robots simply don't. Let me go back to Kieran and Niamh. Conor and Niamh. Sorry. Yeah. So, what are the challenges that you had in developing your robot? I don't know whether you had vision challenges or any sort of maneuvering sort of challenges. What are the things you can talk about in terms of your developmental progress that you found difficult or challenging?
Well, I'll start now. There's really no shortage of challenges. It's a long list. I suppose some of the bigger ones would be, certainly with a robot like Stevie, as we're going to see in here, there's a lot of degrees of freedom in the system. And I guess, the hard part comes, the interesting things come really only after you've got the fundamentals there. So building a system so that when you press an on button, it starts up, it's able to move around, it's able to express emotions and so on. Getting the number of different discrete points of failure in that system alone is very, very large. So trying to build a system where the low level electronics, power supply, onboard computers, that they can all talk to each other and just do basic message passaging, even in spite of great software that's out there, open source software that's out there, it's just tremendously difficult. So it took us a number of years actually just to get to a point where our system was reliable and so on. I think the next big problem we faced was integration. Taking something that works well in a lab and then translating it into the real world presents many issues. And I think Jonathan touched on some of the issues around sensing, but fundamentally, these robots aren't fully autonomous. They do require people to take ownership and play a leading role in their integration and the rollout. And certainly in areas like healthcare where there's chronic staffing shortages, and in fact many of the staff that we would have worked with, like that type of role typically has a high turnover, and many times these are people who don't have a lot of technical education. So trying to be able to get something that's easy to use and also incentivize the people who you need to make sure that they adopt it. That is not straightforward at all. And whether it's in nursing homes or in hospitals, that's a problem that I think will persist regardless of how good or how market ready the technology might be.
Niamh, would you like to comment?
Yeah, just to kind of add to that, it's definitely, I find the hardest part of robotics is trying to anticipate how people will interact with the robot. So one of the things that we were doing with Stevie was we were trying to build out its social intelligence, and how does a robot interact with a group of people? Who does it talk to? How will the people react? Trying to actually kind of gather all this information and build the software to develop the robot to be able to have a simple conversation was really hard, just to even anticipate or think about how that might look, because it hasn't really been done before, so you don't have something to copy. So definitely anticipating how people interact with a robot, trying to kind of guess that and build out software to allow that to happen with Stevie.
Okay, Niamh. Now, could you elaborate on what you just said, or maybe take it one step further forward and Talk about some of the progress that you can possibly see with these two robots that I'm looking at on the screen. So you got Violet, the germ-killing robot, which is an ultraviolet disinfecting robot, I suppose, which obviously, you know, at the moment, I imagine is in very high demand in the coronavirus. And you see, even before the coronavirus, there was hospitals that were talking about super bugs or whatever they, you know, and this kind of robot could actually help eliminate or reduce or maybe even eliminate that. So I just wanted to, you know, ask you about the progress of that as well as Stevie. Now, Stevie, at the moment, it might be just more of a social sort of communication robot, which can move around. But, you know, as you know, with elderly care, there might be a demand for helping people to move from place to another, get out of bed, get into bed, move from one place to another. Do you see that kind of progression at your company or any kind of, what kind of things that you imagine developing in the future?
Yeah, I definitely think with Stevie, I actually even see more of a need now. I know we are quite focused on Violet for the moment because there's such high demand for Violet, but I don't know about where you are, but here there was a huge problem with the coronavirus in nursing homes, and they had to completely shut down nursing homes. There was no visitors able to come in and out. And, you know, from the amount of research that we've done with Stevie, we really know as a team what an impact that would have on older people not being able to interact with visitors, not being able to see friends and family. And really, you know, they suffer, people in nursing homes suffer from social isolation and loneliness enough as it is. And without having people coming in, you know, I can only imagine how much worse that was. So I definitely do see even more of a need for a robot like Stevie. And I suppose Violet kind of came from our studies with Stevie. You know, we were piloting Stevie in nursing homes in the US, and everyone said to us that superbugs are such a huge problem in nursing homes, and that, you know, it's a problem that's not being tackled. And so I suppose we started using UV even before coronavirus outbreak.
Just to kind of build on what Niamh's saying, and maybe kind of add more the kind of commercial strategy that we're trying to apply here. Looking at Stevie and Violet, it might seem like two quite different robots, but really fundamentally, they're both trying to address, you know, what are growing public health issues in the area of healthcare. With Stevie, we started off, you know, seeing an aging population and just a massive supply shortage for caregivers. One of the big problems we actually saw in nursing homes during that time was just you know, how they were struggling to stay on top of infection control. There's actually more people who have healthcare acquired infections in nursing homes than hospitals, and very often, you know, hospitals actually have to deal with a significant burden, and that is, you know, older people who acquire an infection in a nursing home and actually have to get medical treatment for that. So that costs a huge amount of money to care for, and equally it provides lots of challenges for hospitals because someone might go in with a, you know, hip problem, that, you know, maybe go in for a surgery that should take a week, but they end up spending a month in there, which again it has a crippling effect, and then, you know, they might be discharged from the hospital, go back to the nursing home, only for that, you know, problem to get worse, then have to be readmitted to the hospital. So for us, like, the journey to develop disinfection technology began actually at that insight. And it was only when the coronavirus started to become you know, the pandemic it is now, did we see an opportunity to kind of take elements of what we were doing with Stevie and just bring it to market sooner. And that's really what Violet is. You know, Violet is a way for us to take, you know, a number of different technologies that we were working on in Stevie, kind of put them all together in one piece, and to really kind of focus it into a, you know, a problem that is being experienced globally. And now, like, you know, and kind of, I suppose one of the reasons why we were interchanging discussions earlier with Stevie and Violet was largely because, you know, the same software stack that we were developing for Stevie, we've been actually able to retrofit it to the Violet platform. And like, you know, speaking to the versatility of the platform that Niamh mentioned earlier, like being able to, like, a lot of these computer vision algorithms, they're really required in any application of these robots. So I suppose, you know, the short progress we've been able to make has largely been, you know, due to the fact that we have a lot of, you know, expert knowledge in the area of infection control and the efficacy of UV lighting, but also because we've got a lot of experience building robots. And I suppose those two things coming together has enabled us to move quickly over the last number of months.
Okay, thank you very much. Jonathan, could I come back to you and
Sure.
ask you about deep learning? Because as I say, I wanted to know what deep learning is. You know, as far as I understand it, in the case of, for example, Akara Robotics, right, if they collect vast amounts of data through their robots, they can maybe, you know, have the robot learn things from that data. I don't know how I don't really know how that differs from machine learning, for example. So if you could...
It's a flavor of it, absolutely. And I think you hit the nail on the head there. You know, even the word machine learning, you know, what you're doing is you're programming with data. You are showing it millions, if not billions of data points, and then you're telling it, okay, you know, to take the most obvious example is classification. Okay, this is a supervised technique where you have a picture of a cat and you say, this is a cat. And then you ask it, okay, is it a cat? And if it gets the answer right, you strengthen all those signals. If it gets the answer wrong, you weaken the signals. And you just do that millions and millions of times. And what you end up with is a function. They call it a neural network. It's a graph. It doesn't really matter. But it's basically a function that you pass an image into and it will spit out a value. I am looking at a cat, okay? And like that's deep learning is just a flavor of it. Essentially, it's a 1980s version of a neural network, a feed-forward neural network with a large autoencoder bolted onto the front of it. That's the deep part of it. But essentially, it's just programming with data. And, oh, sorry, yeah, go first.
No, go ahead, Jonathan. Go ahead.
So what was nice about this is, I mean, Intel has a thing called OpenVINO. So when you're training a network, you have to run it millions of billions of times and tweak all the parameters, which are called weights, in order to make sure that you're getting the right answer. And what you have is, once you've trained a network, okay, you're finished. You don't have to change those weights anymore, and you can freeze it literally, and then you can just run it. Okay, so every time you pass it an image, it'll tell you something, but it's not going to train or update anymore. And that's how we make our chips low power. A lot of the networks that, you know, you have to have a big GPU to train it, but once it's trained, you can optimize that network, cut out all the redundant stuff, and make it run much faster and on much less power on hardware. And we use a thing called OpenVINO. So this is Intel's approach to making a generic way of, so you take a network that's been trained on a GPU. If you try and run it directly on a CPU, it is quite slow. But if you use OpenVINO to optimize it, you can optimize it for the underlying hardware, and then you can make it run on a CPU much faster, or you can make it run on a neural compute stick much faster, whatever you want. So there you go, FPGAs or Movidius VPUs. We can take the networks, and because they've been trained, we can then optimize them to run on the hardware at low power and high speed. But another really nice thing is, with OpenVINO, there's a model zoo. With a lot of deep learning frameworks, there's a model zoo. You don't necessarily need millions and billions of pictures of people or whatever you're, you know, trying to do. You can just download a network that automatically has that has been already trained and optimized for the underlying hardware. So if you do Model Zoo OpenVINO, you'll see like all the different types out there, and you can just take them and use them exactly like a function. So there you go. And face detection, person detection. You can use it to detect malware. You can use it for, you know, all sorts of stuff. Vehicle detection, automatic driving. You know, you don't need to train it. It'll just automatically work. Text recognition, stuff like that. So the nice thing is you can take these models and then just run them on our hardware and it'll automatically work for you. So you don't even need to train it yourself.
Hardware, including that the cameras that we've been talking about in this interview.
Yeah, so it'll take you can, once you've resized the data and you have it in the right color space, it should work with any camera.
Yeah, it's really interesting, and I mean, it's difficult to explain abstract concepts to people, and this is something that I can understand. If you've got a robot or the robots that Akara are developing, you can see deep learning learning opportunities for this robot in particular, because there are so many things involved in the care of elderly people or any kind of people, really. As I say, whether it's moving them around or bringing them little items and objects from one place to another, running errands and whatever. So there's loads of things that you could end up doing with a robot like this. The other one, if it's a straightforward disinfecting robot, I'm not a roboticist, but I don't know how you would develop it. It's like optimal, I suppose. But what do you think, Jonathan? What kind of things do you think this kind of robot with deep learning is capable of doing, given the tools, ready-made, off-the-shelf tools out there, like the list that you've shown me?
Can we go into the perceptual stack of Stevie at all? I don't know if is that okay with you guys? Or
I suppose high level.
at a high level. So yeah, if we have a robot that's capable of navigating, it has a map of the space, but it needs to detect, for example, if a person is in front of it, and if it does, it can then interact with that person. It knows it's a person, so it can say hi, and then it can navigate around it. All of these this is basically increasing its ability to perceive reality. That's I think at the highest level, that's what you can do. If you've got a camera, it's just going to return a bunch of pixels. That's going to make no sense to it. But if you can then use these kind of deep learning techniques, these machine learning techniques, to go, okay, these pixels represent a person, or these pixels represent, an object or something like that. Then the robot can use that information much more easily than just pure camera data. So I think for it to interact with the real world, it kind of has to have these things on it. And I think that's where the kind of field of robotics has increased massively in the last 10 years, is we're able to do that sort of stuff now. Whereas before it was only on very limited cases could we do computer vision. If we controlled the lighting and everything absolutely perfectly, it worked. But now we have a lot more capabilities.
Yeah, that's an interesting thing. One of the things that somebody said about smartphones is that they're basically, because of the scale of success that smartphones have enjoyed, sensors that used to be really, really expensive before are now affordable for startups like Akara. As you yourself have noted, that there are systems that are very expensive that cost thousands of dollars that now you can supply for a couple of hundred or whatever. So yeah. I'll go back to Conor and Niamh and ask them, what do you think as I say, what do you think your future will be, both in terms of business as well as the kind of technology developments that you foresee integrating into your robots?
I think our short-term goal is to develop an infection control platform that results in hospitals, nursing homes, and really any other setting that requires them to be safer than they were before, and also safer than any other platform that's out there. So we're actually looking beyond developing a robot. It's actually developing a whole system whereby the robot is able to work as a kind of a critical link in the chain, so to speak. So trying to work with organizations to see just about how they can change their kind of the standard operating procedures so that they can actually allow these places to be safe for people to come back to. We see in hospitals, places like Ireland, the prevalence of COVID amongst healthcare workers has been really high. It's been between 20 to 30%. So even that tells us very strongly that we need more than just a robot for this to be effective. So our goal right now is to find partners that will help us pilot these new systems, and the hope is within the next 12 to 18 months we can really show that if you work with us and with the technology, that we can bring meaningful impact to the organization. I think beyond that, we as part of that process, we will be developing significant operational capability for these robots, and as part of our kind of long-term R&D roadmap, development is continuing and probably will increase at a faster pace on Stevie. We expect that the key aspects of the interactive technology that we've been developing with Stevie will start to filter down a little bit to the Violet platform. So this isn't going to be something that requires a PhD to learn how to operate. We can hopefully develop something that can work very intuitively alongside people. And we hope that over time we could start to work on pilot programs with Stevie where we could really start to tackle some pretty big problems, especially in areas like dementia and Alzheimer's, where it's just not feasible to, and it's not practical for informal caregivers to continue the way they have. This is a sector that, again, it's utterly unsustainable to keep going as we currently are. People, especially older people with cognitive impairment, just reliant on informal care, and it's just something that I think as the workforce starts to shrinken, we're going to see just how vulnerable that sector is. And again, looking at problems like social isolation and loneliness, and seeing how technology like a robot might be able to help. These are things that we think we're not going to trust the marketing division to tell people that this will be the case. Instead, we want to actually prove it and show it, and try to find partners that allow us to do those sorts of pilots. And hopefully we'll see I'd say quite steady progress in this direction.
Yeah, I definitely think COVID has been kind of a catalyst for change in terms of technology. Whereas before, trying to get a new technical cleaning solution into a hospital might have taken a couple of months, even years, we managed within a week or two be able to get a pilot site in hospital. So I suppose that is one benefit from COVID, is that people are seeing now that we need to be innovative in terms of the technology that we use, and not just stick with a process we have now because it works for now or it's useful. We need to be looking ahead and kind of anticipate what problems we have. And so I definitely think that people will see sooner that there's a need for technology like Stevie and Violet, and put effort in now into implementing that rather than saying that's a problem for the future.
Thank you very much for your time and your insights, all of you.
Send us an email at sales@roboticsandautomationnews.com to register for one of our many upcoming webinars. And if you'd like us to host your webinar, we have a range of options, including long-term lead generation packages and marketing campaigns. We look forward to hearing from you soon.